Good day everyone, welcome back to the channel. In this video, we are diving into a powerful way to monitor and optimize your Azure OpenAI usage, something that's absolutely critical during the early phases of AI adoption. If you are using Azure OpenAI services, you know how quickly costs can spiral and how important performance tuning becomes. That's where Azure Workbooks combined with diagnostic logs and metrics comes into play. I will walk you step by step through building a cost optimization and performance monitoring dashboard using Azure Monitor, helping you make smarter, faster, and more strategic decisions for your AI infrastructure. This workbook has helped organizations save costs without compromising performance, and by the end of this video, you will be equipped to do the same. If that sounds valuable, please go ahead and like this video. And if you're new here, hit that subscribe button so you never miss out on more practical Azure AI tips. Let's jump right in. I'll be using the information that's present on this particular blog. I've included the link for this article in my description section of this video, so you can have a look. Yeah, so you have more details as far as this particular dashboard is concerned in this blog. You can have a look and you can get some good details as far as this dashboard is concerned. Okay, now to actually download the required artifacts, what you need to do is you need to click on this repository here, and you will be taken to this particular article in GitHub. Yeah, so what you need to do is you just need to click on code here, and then you need to download the required files. Yeah, once you download, you will see this particular compressed file here, and I've already uncompressed it. And if you see here, inside that folder, you have this workbook folder, and the matter of interest is this particular workbook file. Yeah, I've already opened that in a Notepad++. If you see here, this is the workbook. What I'm going to do is I'm going to just copy it, select all, and then copy it. And then what I'll do is I will go back to my Azure portal. Yeah, yep, and then I will search for workbooks. Yeah, so what you will see is you have this Azure Workbooks. Just click on that, and then what you need to do is you just need to click on this plus create, and then you need to click on this new year. Yep, and then once we have this information, you have this advanced editor here. Just click on that, and then what you need to do is you just need to select everything, or just do a Control A and then paste whatever content you copied from this Azure OpenAI Insights.workbook. Okay, and once you do that, what you need to do is you just need to click on apply. Yep, it's applied now. So now what you need to do is you need to save it, and then you need to name this. Yeah, okay, I'm naming this workbook as this one. Yeah, and then I'm selecting the required resource group. Yeah, yep, and you can select whatever location you want. Let me click on this save as. Let's wait for it to complete creating the workbook, and then we'll take it from there. So the item is created now, so we have the workbook saved. So what I'm going to do is I'm going to just click on this workbook one more time. Yeah, let's go to the overviews, and then let's click on this workbook. And then if you see here, we have this Azure OpenAI Insights Dashboard _ 17 August 2025. So let's click on that, and then let's if you look at this one here, so you are now able to see all the required details. Okay, now if I go through one by one here, yeah, so you need to select the appropriate subscription here. Yeah, and then whatever OpenAI service you have. For example, in my case, I just have only one OpenAI service, but in case if you have multiple OpenAI services, then you can either select all, or you can select the specific OpenAI service that you are interested. Yeah, time range is self-explanatory. You can select whatever details you want. In my case, I'm selecting last 30 days, which is a default one. Yeah, now you have three tabs here. The first one is overview, and then the second one is monitor, and monitor has got further tabs here like overview, HTTP request, token-based usage, P2 utilization, and then fine-tuning. And the final tab is insights. And one thing to keep in mind is like as far as insights is concerned, you need to understand like for each and every OpenAI service that you have, you need to enable the diagnostic settings on that specific OpenAI service and then send the data across to an log analytics workspace. And once you do that, that is when you will see all these details here. If you don't do that, then what will happen is like you won't be able to see any of the details here. Now, if you look at it here, we have the required log analytics workspace. Yeah. So in my case, I'm going to select the log analytics workspace that I've used in my OpenAI service. So let me select that. And in the meantime, while I'm going to get the required details, let's switch over to our OpenAI service here. Yeah. And under monitoring, you have something called diagnostic settings. Just click on that. And then if you see here, I've already added my log analytics workspace. Now, if I click on this edit settings here, what I'm doing is like I'm basically selecting this audit and all logs as far as the category groups are concerned. Yeah, and as far as metrics is concerned, I've selected all metrics, and then I'm basically sending it across to my log analytics workspace. One thing to keep in mind is like this particular operation is going to have some cost associated with it. Yep, and depending on your OpenAI service usage, there is high possibility you might be utilizing a lot of things as far as the log analytics workspace is concerned. Like you might be writing a lot of logs into that, and that can have some cost implications. So just keep that in mind. Once this is done, and once you select the required log analytics workspace, you will be able to see required things here. Okay. Now what we'll do is like, let's go back to our overview section, and then let's look at each and every section one by one. Now, if I look at the details here, what I'm able to see is like we have this count by subscription ID that basically tells us like how many OpenAI resources exist per subscription. Yeah, it helps avoid duplication across multiple subscriptions, and which can maybe like cause common cost leaks. Okay, the next one is count by resource group, which basically tells us the groups of resources hosting OpenAI deployments. Yeah, it helps us identify if test or staging resources are still running in production subscription. That kind of information we will be able to understand. Count by location, it speaks about the Azure region distribution. Yeah, running in multiple regions unnecessarily higher cost, and we can consolidate after looking at the details here. Like look at the region and then see if it is all required, and that's gonna help us as a whole. Okay. Now, if I look at this count by kind, this is like kind of the resource type. Yeah, and it tells you about the deployment accounts, and make sure like only required types are deployed. Okay. The next one is like count by public network access. It shows the deployments where they are open to public network. Yeah, it is always good to have public endpoints disabled to avoid any potential misuse, and then it can lead to wasted cost as well. Yeah, and then the next one is count by private network access. It is secured, and it is kind of a controlled deployment. So always prefer private access to prevent unwanted traffic that might inflate bills. So it's very good if we have things as far as private network access is concerned. Now you see some general details like what's the subscription ID. If you have multiple OpenAI servers, it will be listed here, and then it gives you the details like where these OpenAI services hosted in which resource group, and it gives you the location, the kind, SKU, and things like that. You can look at it, and then it gives you all the basic details here. Yep. Now moving on, let's go to our monitor tab here. Yep, and as far as the monitor tabs are concerned, like we have these details here. The first one is basically your Azure OpenAI request. That's the number of API calls made. Yeah. Now, for example, it helps you in understanding if there is any kind of spikes. It helps you monitoring the spikes as far as the request is concerned. And if you see, this can clearly tell you like if there are any unnecessary repeated calls. And in case if you have something of that sort, then that can result in higher token cost. Yeah. The next one is your processed inference tokens. That's the tokens consumed in generating AI response. Yeah. So you need to track this carefully. Inference tokens drive most of the bill. The next one is like your processed prompt tokens. So this is the tokens consumed in sending input prompts. Yeah. So in case you have long unoptimized prompts, then it can result in more costs. And then it's always good to use shorter and reusable prompts. Next one is generated completion tokens. That's the output tokens from model responses. Yeah. Larger completions inflate costs, and also like it's always good to cap your max underscore tokens parameter just to make sure like you have a check in this. Moving on, let's look at this processed fine-tuned training hours. Yeah, so that one is the hours spent fine-tuning the models. Training is expensive. Monitor and stop unnecessary fine-tuning jobs. Yeah, the next one is provisioned managed utilization. That's the utilization of provisioned throughput units, PTUs. Yeah, underutilized PTUs is kind of wasted money. So in case if you have PTUs, in my case I don't have that. In case if you have it, you look at this one and then adjust allocation to match your demand. Now looking at the next one, which is your active tokens, that's directly reflects the currently in use tokens. Yeah, and it helps track your workload size. Watch for idle unused tokens to make sure like whatever tokens we have is getting used properly. Next one is prompt token cache match rate, and this one is the percentage of reused cache prompts. Yeah, higher cache rate basically tells you that you will have lower cost, and it is better to optimize prompts for reusability. Next one is time to response, which is basically the latency in model responses. This is quite important as far as performance is concerned. Yeah, longer times can mean inefficient model choice, which basically means that we are wasting cost as well as the performance is not that great. So that's something that you need to keep in mind. Now, if you look at the next tab, which is basically your HTTP request. Now, let's wait for it to come up. Yeah. So now the first one is basically request by model name, or the model version or your deployment name. So you have these things here. Yeah. So basically like if you see this, it basically tells you or you can identify which model consumes the most cost. Yeah. So for example, like if you have multiple models, then you will be able to see those models. Yeah, like what is the model name, what is the model version, and then also like corresponding deployment name. Next in our list is request by status code. So it's basically like translates to error rates. Yeah. So now, for example, if you have much of an error kind of thing, then that's going to be wasted calls and still build partly. So in case if you see something of that sort, you need to act fast and fix quickly. So the next one is request by stream type. This is the streaming responses versus single shot completions. Yeah, streaming may generate more tokens, so you need to have a look on this particular thing. Yeah, and if we discuss about the request by operation name and then the API name, it shows what operation, example, whether it is going to be a chat, completions, or embeddings that are driving costs. So you will be able to understand which is basically doing that, and then you can go back and then look at things. Yeah. And then now this request by region, it is basically like going to tell you like where is the request coming in. And for example, if you're kind of seeing regional duplication, that can increase cost. So what you need to do is like you need to look at the usage pattern, and then you can try consolidating the usage. Okay, and then time to response by model name and then deployment name. It's going to be like it basically tells you the details of the response. Like it's mostly like you will be able to understand how good is your model performing. Yeah. So some models may be slower. So consider cost versus latency trade-off. So it basically look at these things and then look at the cost and then select whatever is required. Yeah. The next one in list is your prompt token cache match rate, and this is for your model name and as well as for the deployment name. Yeah, and see which model benefits from caching. Yeah, tune accordingly, and that's really gonna help you. Okay, next on the list is your token based usage. The first one in this list is your processed inference tokens by model name, by deployment name. It basically talks about the inference, prompts, completion tokens by model or the deployment. Yeah, spot which models are over-consuming tokens, optimize prompt engineering, or switch to cheaper models if the usage is really very high. And that's something that you need to do here, just to make sure like you are looking at the usage and then spot things and then take appropriate actions. Processed prompts token by model name and then deployment name. Basically like same thing where you need to spot which models are basically taking too much tokens, and then you need to optimize the things accordingly. Yeah, and then generate completion tokens by model name. So this is the tokens that is utilized by the OpenAI service. Yeah. Now, in Azure OpenAI, when you send a prompt, yeah, to the model, it processes that and generates a completion. Yeah, the output text is measured in tokens. Generated completion tokens by the model name. That's the count of output tokens produced by a specific model. Yeah. So now we know that completion tokens are billable. So now if you have so many completion tokens here, then that you can understand like that's gonna really going to increase your cost. Now by looking at the model name and deployment name, if you can understand that, then you can either fine tune the prompt or look at why you are seeing too many requests, and then you can work on that further. Okay. Now if I talk about the active tokens by model name or the deployment name, you need to monitor the growth, and then you need to stop unused or over provisioned deployments, or either like look at it like why it is like sending too many tokens and things like that. You can have a discussion and then you can do it further. Yeah, maybe like you can fine tune it further. Now looking at the PTU utilization, as I told you earlier, I am not using PTUs, that is the provisioned managed utilization thing. Yeah. So now, if you look at the things here, you have this PTU provision managed utilization by model name and model. For example, if the PTU utilization is less than 60 or 70%, then you are basically overpaying it. Yeah, you can either scale it down or you need to increase the utilization. Yeah. Now, if your PTU utilization is greater than 90%, then there is high possibility you are risking the throttling, and either you need to optimize it or you need to scale up. Yeah. Provisioned managed utilization by model deployment name or by the stream type. What it basically tells you is like how much of your reserved PTU capacity is actually being used for given model deployment. Like you can look at the model deployment and then you can understand that. Yeah, if the utilization is low, then you are overpaying for the unused capacity. And if the utilization is high or maxed out, then your app might phase throttling, just same as the previous one. Yeah. Now looking at the provisioned managed utilization by region. Now this one will basically tell you like which specific region from where you are using the reserved PTU. Based on that, you'll be able to understand like from this particular region you are getting more requests. So you can have a look on that, and then you can maybe like fine tune it depending on the requirement. You will be able to understand what is going on. For example, if in one region if you're seeing too much requests, then you can concentrate on that, speak to the concerned team, and then understand if this kind of traffic is normal. If yes, that's fine, or else you need to like fine tune things there. Yeah. Now moving on to fine tuning, we have this process fine-tuned training hours by model name and deployment name. Yeah. So now, as far as the fine-tuning is concerned, it is one of the most expensive operations. You need to monitor it very, very carefully. Turn off unnecessary runs and reuse existing fine-tuned models instead of retraining it repeatedly. So you can look at those things, yeah, and then you can come to a conclusion. Let's move on to the final tab here, which is Insights. Let's click on it. Now, as I told you earlier, we have these four tabs under Insights, and then you need to keep in mind that you need to select appropriate log analytics where your diagnostic data for that OpenAI service is getting saved. Yeah, only if you do that, you will be seeing these details here. Yeah, for example, if you see here, we have this request by resource, location, stream type, and then the API version. So what we need to do is like we need to spot any kind of unusual distribution or unexpected regions using the resources that could drive the cost. Yeah. Next on the list, we have this request by deployment name, and then the operation name here. Yeah, the model name and the operation name, and this basically identifies the most expensive combination of model and operation. Yeah, so you basically have to look at these things, and then you can get the details related to the expensive model and operations. Yeah, moving on, we have this by caller IP, and if you see here, we have the request by caller IP, and then you have the informations for the other things like the operation and model. And what it basically gives is like it is basically an useful thing for catching misuse or unapproved apps into the API. Yeah, so you will be able to look at the IP address, and then, for example, if you see like there is too many requests that is coming from any particular IP address, and you can have a look on that and then see if this is something related. And now what you can do is like you can speak to that particular application owner and then see if this IP address is said to send this much of request, and using that information you can get more details. Yeah, so here if you look at it, it basically tells you like what is the operation, and then it gives you the count, and also like it provides you the duration and also the average request you are getting here. Yeah, and then for this one, which is basically your request from the model name, it basically tells you like what is the model that is used here, and then the other things are mostly same as this one, but this one would be able to differentiate like from which deployment and from which model is that the things are going up like as far as the request, and then you can get more details on that. Yeah, now you have many filters here. You can select the filters, like since I have just one deployment and the OpenAI service is also one, it's pretty easy for me to look at things. But in case you have multiple things, then you will have to use these filters to zero in on the required things. Yeah, now as far as the all logs is concerned, it basically kind of looks at all the successful requests. Yeah, it kinds of tracks your baseline usage, and then you can use it to compare with the billing thing. Yeah, and same way you have things for failures, and it basically tells you the failed request, just in case you have any failed requests by resource, API version, operation, and then stream type. Yeah, failures still consume some tokens. That is something that you need to keep in mind. So it is high time, in case if you see any failures, to look at it, and then you basically fix that one. Yeah, so you basically have to fix the misconfigurations quickly to stop any kind of cost leakage. So, as far as the key things to monitor for cost savings, you basically have to look at the prompts versus completion tokens, or optimize prompts and then cap completions. Yeah, inference tokens usage. It can be used to track which model drives token cost, and then the model choice, like use a lower GPT version or embeddings instead of an newly released one where possible. That's the most important thing. If it is going to help you, you can do that, and that's gonna bring the cost to a greater extent. But the response would also be like comparably not that great as far as the higher version is concerned. Yeah, concentrate on the PT utilization. You basically have to scale resource capacity up and down based on the actual usage. Yeah, and then you look at the failed requests and errors, and then stop unnecessary retries that waste tokens, and then look at the fine tuning hours. Avoid redundant fine tuning. Make sure, like, if you can reuse it, that's going to be really, really good. Look at the cache match rate. Increasing the caching to that's going to save you a lot of repeated token usage. Yeah, and also, like, by caller IP, if you look at it, watch for unapproved workloads eating into cost. In short, monitor tokens, model usage, PT utilization, and failures. These are the biggest levers to slash Azure OpenAI costs without hurting performance. That's it for this video. Thanks for watching. Have a great day. Jai Hind.